Okay, hey everyone, good morning. Hope everyone's having a great time at Summit so far. Thanks for joining us today. We have Gerald Knackley from Atlassian, and he is presenting on reimagining data governance and access. So everyone give a warm welcome to Gerald.
Thank you. Good morning, everyone. I'm Gerald, and I'm an engineer at Atlassian, where I work on our internal data platform, or data lake. And I'm here to present our work, reimagining data governance and access at Atlassian, which should hopefully give you an inside look at how we manage access controls and our policy architecture on our new data platform, a lot of which is held by being on Unity Catalog. For those who don't know what Atlassian is, we're the company behind tools like Jira, Confluence, Bitbucket, Rovo, Loom, and about 15 other team collaboration projects. Maybe a show of hands, anyone use any of these products? Oh, wow, great. So here's what I have in store for you guys today. It's gonna start off with the intro, where I talk about our data lake and give you the landscape of our data platform. And I'll talk about Socrates V Classic, which is our legacy data lake where we weren't on Unity Catalog, based on Hive Metastore. And I'll give an overview of the architecture of the solution we've built in our new data platform around policy components. And then I'll mention our new data platform, Socrates V Next, where we are using Unity Catalog and the benefits we got from it. And finally, some key takeaways and future plans for data platform. So what is Socrates? Socrates is our internal analytical data lakehouse. It's useful to know why things are named the way they are. So Socrates is in reference to the Socratic method, which is a form of cooperative, argumentative dialogue between individuals based on a Q&A to stimulate critical thinking and to draw out ideas and underlying presumptions. Two things to note that'd be useful to know. So I'll be mentioning the talk Socrates V Classic, that is in reference to our legacy data lakehouse, and Socrates V Next, it'll be referencing for our current next-gen data lakehouse. If you want to know more about Socrates V Next, my colleagues last year did a talk, which a deep dive on the VNext platform and how it's built, if you want to know more. So some quick stats on our lakehouse: more than 100,000 tables, more than 1,000 databases, more than 50 petabytes of data in our data lake, and more than 5,000 data users. And an interesting stat I learned the other day was over 80% of the company staff use data in their day-to-day job, which is good. You want to be data-based in your decisions, so that's a good metric. And you might have noticed these numbers are quite big. It's hard to argue that all of these tables are quite useful. So as the policy and access control stream, we aim to empower data practitioners at Atlassian with tools to manage and protect their data while optimizing for developer productivity and ensuring that users have access to the data to do their job. So we have 3 goals as a stream. One is to promote customer trust. So we want to make sure data is tagged and classified. So if you have a table with a column that contains PII data, we want to make sure that you can classify and tag that data as such. We also want to make sure data has an accountable steward. So if things go awry with data, or if you have questions around tables or data, you know exactly who to contact. Also, we want good auditing capabilities. There's more and more rules and regulations around data, how you use them, and a lot of internal audit requirements. So being able to provide an audit trail for data and how they're used becomes more and more important. We also want to promote developer productivity. We want to have like a single pane view for access controls and data governance on our platform. We don't be going through Databricks, AWS, and a bunch of other tools to find out what policy or what access controls apply to which data. We also want access grants to be straightforward, such that it's easy to understand, and if access grants and data governance is simple to understand, you get less questions in your internal help channel, which helps everyone save time. We also want to be self-service. A bit more efficient if it's self-service. And we want to ensure time to insight. So we make sure users have access to the data they need to do their jobs, and that data insights are available, so that's such that you can make data-backed business decisions. So I'll start to talk about SugsB Classic, which is our legacy data lakehouse, where we were not on Unity Catalog, which is based on Hive Metastore and a lot of IAM access controls, and the challenge we faced with it. So in our internal Slack channel, where the user of our platform can ask questions, a common question we get asked is, how can I find out who's querying my table, and how can I find who owns table X? So a quick Slack search for who owns in our Slack help channel. Over 210 messages. That's a lot. And 2 files. Not sure where that came from. So this is a clear issue. And if I had to categorize the challenges we faced in our old data lakehouse, it would be under these 3 themes. So governance security. We had rudimentary governance and guardrails. Challenge with operational efficiency. A lot of manual work was involved, and we started scaling issues, limits, things like this. Collaboration left a lot to be desired. There wasn't clear who owned which data, and like guardrails around what gets promoted to production. And diving in a bit deeper into each of these ones. So around governance and security, permissions were tied to the Databricks cluster. So our permissions were based directly on IAM. So users' permissions on S3 buckets would come from the IAM instance profile that's attached to the EC2 instance, which makes up the Databricks cluster. And in effect, the access control list of a Databricks cluster becomes our point of where data access policies are enforced. This is not ideal. Ideally, you'd want to be tied to the user themselves rather than the cluster or things around this. We also used IAM credential pass-through for access on specific types of data. And it was a bit of a complicated setup. If you've used this before, you have to set up a high-level meta role, which is used by the cluster, which has permissions to assume different roles that have access to the buckets you require access to. So it was complicated, led to a bunch of provisioning of IAM roles, and it was a bit buggy at times. And auditing was also a difficult task. It was hard to pinpoint which user executed which query, because a lot of times user identity was lost when queries were executed. In terms of operational efficiency, every new zone required manual steps from the platform team. What is a zone? Every piece of data work begun usually with a zone being provisioned. You can think of a zone as a database or schema, and your tables live under that zone schema or database. And a zone comes with a lot of things associated, provisioned as part of it. So you would have a IAM instance profile and role associated with it, a group for access to that zone, and a cluster as well. And because of this setup, this led to an explosion of IAM instance profiles and roles. It became hard to manage. And because we were on Hive Metastore, which is bound to the workspace, a lot of the same policies were applied. The same policy was applied across different workspaces because we had different workspaces. And we had begun to hit a bunch of limits. So there were some AWS glue limits we're starting to hit. A lot of the roles were starting to hit the character limit for the policy associated with the role, some Databricks limits as well. And around collaboration, data discovery was a difficult task. It was hard to find reliable and trustworthy data sets and dashboards. There was an attempt internally to build a tool for this called Data Portal, but development for the tool had stalled and sort of became orphaned and a bit buggy, and sort of became not a usable tool for data discovery. So that became a bit hard. Data ownership and stewardship was not well defined. So if you had issues with data quality issues or usability issues with a table or data, it wasn't clear on who to contact regarding that. We also had like shadow production tables. So a lot of times a table would be used for production data sets, but how the table was, other being a production table, was produced by a notebook by someone who had left the company, and you end up using a data set which isn't maintained, and you didn't know who to contact for it. So we had some issues, and we came up with a solution, something around policy components. and our architecture looks something like this. So we offer 2 types of policies, and now this is like our new data platform. So we offered coarse-grained policies, which provided the read access to your table, and then fine-grained policies, which are able to restrict access to specific rows and columns. And it's a bit built around these 4 tools. So starting off with Vaporeon, that's our internal data control plane. SSAM, which is Atlassian standard for groups and group management. Unity Catalog as our policy enforcement layer, and then Immuta for our policy management layer. And diving a bit deeper into each of them. So Vaporeon is our data control plane. Every piece of data begins its life by being registered into Vaporeon, where it is submitted along with its metadata. So you'll be submitting your schemas, your tables, policies pertaining to each data object will be submitted to Vaporeon. And this is also where data is on board third-party systems, such as Databricks, Immuta, things like this. And for SSAM, this is Atlassian standard for group and group management. It's a self-serve tool, and users would provision a high-level access container, and within that access container, you can have multiple sub-access levels which users can control the memberships of. And then we sync those group memberships into tools to be used as a mechanism for granting access. And this is how human access is managed. Unity Catalog, so when a piece of computer is run, Unity Catalog is what actually enforces the policy on the data. So this is our policy enforcement layer, and we also get a lot of governance and lineage from Unity Catalog. And Immuta is our policy management tool. Policy management can be a complex area. What Immuta takes care for us is with fine-grained controls. You write your data policy once, and whatever cloud data platform you use, whether it's Databricks or Snowflake, it takes care of syncing that into the cloud platform's native syntax. So this is what the high-level architecture looks for coarse-grained access. So you have your table descriptors, which are a YAML file, which reference policy descriptors, another YAML file, which is then submitted to Vaporeon, which is our data control plane, where operators pick each descriptor up, and it provisions resources pertaining to that descriptor into whatever system is relevant for that descriptor. So user would submit a table descriptor, which is a YAML file, which is its spec, and then Vaporeon would pick the descriptor up, and based on the fields the user enters, it provisions resources. So in this case, for a table descriptor, it goes to the table operator, which creates a table in Databricks. For the policy descriptor, it's picked up by the policy operator, which creates a group in Databricks, and that group is granted access to the table in Databricks. There's also a piece there on the group membership sync. I mentioned the SSAM tool, which is the tool we use for groups and group management. And we have a sync process which syncs each group and its members into Databricks as a group. So for the user, this is what it looks like. You have your table descriptor, which has fields such as name of the table, summary, and ID, a field for columns, and it is tied to a policy by the policies field here, and that is referenced to a policy descriptor. And the policy descriptor operates under the premise of conditions and actions. So if a certain condition is met, then the declared action is performed. In terms of what resource is provisioned, what Vaporeon provisions to the system with a table descriptor, a table is created in Databricks, so just a table in Unity Catalog, and with a policy descriptor, a grant is issued. So the group you reference under conditions, the sales group, is granted whatever permission is declared in the descriptor to the table. For fine-grained access controls, this is where Immuta comes into the play. So a similar story here. You have a table descriptor which references a policy descriptor. In this case, it's a fine-grained policy descriptor. And it's submitted to Vaporeon. And the Vaporeon would create resources in Immuta this time for fine-grained controls, which is an Immuta. The table operator will create an Immuta data source. And data source is just Immuta's concept of the table. along with tags on the column to the data source. And the fine-grained policy descriptor will create a data policy in Immuta, and Immuta will sync that data policy into Unity Catalog in Databricks. It does this through a mechanism of a UDF. Similar process here for the group membership sync, where groups are synced into both Immuta and Databricks, such that they can be referenced for data policies and access controls. So for descriptors, this is what it looks like. Same deal with the table descriptor. What's pertinent here is the classifications field or tag field where you tag your data. And in the policy descriptor, you reference these tags under the conditions field like so. And if the condition is met, you will declare a certain action. In this case, a bit hard to see with the black box, but in this case, the action is hash masking. So the fine-grained action here is to mask the data with the hashing mechanism. We have different types of actions for fine-grained controls. One of them is null masking, so you mask the field with a null value. We also have support for row redaction. So in terms of things being provisioned, the additional steps for fine-grained controls is a data source is created in Immuta, which looks like that. And the tags on the columns are also synced. So we can see here that on call 1, the classifications data type UGC raw is synced there as a tag on the column in Immuta. And if you expand the tag, it looks something like this. And you might notice it's hierarchical. So it's classifier dot data type dot UGC dot raw. And that allows us to create hierarchical policies. So for example, if I had a policy that was applied to classifier data type UGC, that would also apply to any downstream tags that are more specific. And with the policy descriptor, a data policy is synced into Immuta. And you can see which fields are controlled by the mapping from the YAML into Immuta. So the actions field maps to this area in the data policy. So this is the fine-grained action. And the labels for which the data policy applies to on which columns is controlled via the labels tag. And exemptions are, so who should be able to see the unmasked data is controlled via the exemptions group. You can see it's mapped over here. And one thing to note here is we've mapped the policy descriptors in the descriptor terminology instead of the implementation detail terminology. So if we were to change the Immuta out for a different tool or something like this, the descriptor would remain the same for the user, and they would not need to change anything on their end if we were to change the underlying implementation detail. So our new data platform starts vNext, where we're a Unity catalog. There's a bunch of things we gain from being on there. And going through each one on the governance and security space. So permissions used to be attached to the bucket and IAM role, but now it's tied directly to the Databricks user. In our old platform, access to tables was either to every table under schema or nothing. And with Unity Catalog, it can be scoped to specific tables. So you can grant someone access to a specific table without granting them access to every other table under that schema. There was no fine controls in the old data lakehouse, and now we have finer controls via row-level security and column-level masks in UC. Audits were usually done via CloudShare logs, but in UC, it was via built-in system tables. On the operational efficiency front, Lineage required external tooling, but it was just built in UC. Databricks user and group management was per workspace, but now we sync it once to the account, and then we then reference that. We then federate those account level groups and users into workspaces and reference them there as such. There was no performance tuning in the old lakehouse, but now we get predictive optimization for performance tuning, and that's enabled on every table on the platform side that is provisioned by us. IAM roles was usually per cluster and per team, but now we use storage credentials, which is defined once and shared. External data source integration required custom tooling, but now it's integrated directly on UC. So if you had like a Snowflake data source, you could ingest that in UC via the built-in Unity catalog integration tool. On the collaboration front, custom tooling was required for data discovery, but now it's built in with Unity catalog. There was no AI integration, but now you have the assistant and AI BI Genie built in. Data ownership was a bit better, and there was no Delta shares previously, but now we have Delta shares, which we use a lot. And most importantly, no emojis, but you can have emojis. Please laugh at my attempt at a joke. Thank you. So one thing you may notice is many useful features and simplified governance models came out of the box, and a lot of times for free. So finally, some key takeaways and future plans. Governance is hard to retrofit. They should be in place from day one. If you notice the statistics from early on the slides, we didn't even try to put governance on the scale that we had in our old data lakehouse. It was just impossible. So we did a big bang move and made sure that governance was in place from day one with our new data platform. Understanding use cases and access patterns. This helps in simplifying the terminology for users to use the tools you built and make sure it's also actually used. And making sure that it's simple and easy to understand is helpful in this case. If it's simple and easy to understand, you get less support questions, and it also gets used a bit more. Some future plans, we want to implement purpose-based access controls, data retention rules via the policy descriptors, automatic sensitive data discovery, and integrating data domains into the platform. Hopefully that was somewhat useful to you guys. Thank you for coming through and listening during the lunchtime. I got a notification in my app that lunch is being served, so I appreciate you coming through. And if you're looking for a job, we might have one for you. So thank you.